Chapter 4, we're going to look at understanding and comparing distributions. When you're analyzing data, it's best to start with a high-level view. So start with a 5-number summary, a histogram, and a box plot. Those three things are going to give you a very nice, high-level, big-picture view of the data set that you're going to be working with. We'll look at this example. This is an agility test for 4th grade students. Now the children jump side to side across a set of parallel lines, counting the number of lines they jump in 30 seconds. The data set below that shows the counts of the lines that were jumped for each student in that 30 seconds. And below that we have the 5-number summary. So the minimum is 12, our Q1 is 19.5, our median is 2, our Q3 is 25, and our maximum number of lines jumped in that 30 seconds is 29. So here's a histogram of our data, and let's take a look at that. What can we say about that to describe it? Well, it's unimodal. We've got a peak there at 22 lines jumped. It looks like we had 5 students that jumped 22 lines in the 30 seconds. It's approximately symmetric, and that is approximate. It's not exactly symmetric, but remember, it doesn't have to be perfectly symmetric as long as it's approximately symmetric. There's nothing there that shows any skewness one way or the other. So here's a box plot of our data, and we can see our Q1, our median, and our Q3. We have our whiskers there. Box plot doesn't show any potential outliers. Now this box plot is different from the one that we looked at in Chapter 3, because the one I drew in Chapter 3 I drew by hand, so I did it horizontal. And it's just easier for me to draw the box plots horizontal. Software packages tend to do them vertically. So this one is just shown vertical. The one I drew was shown horizontal, but it still has all of the same information on it. So now we're going to look at the same data, except we're going to break the students up into 2 groups. We're going to have a data set for boys and a data set for girls. Okay, and we're going to compare the two. Same data that we had before, same agility test, same students, and the same number of seconds that they have to jump side to side over the lines. So now I have a 5-number summary, but I have it broken out by boys and girls. So if we look at it here, we can see that the minimum value for boys was 17. For girls, it was 12. We've got a median for boys of 22 and a median for girls of 23. And then a max for boys of 29 and a max of girls for 28. So here are the histograms for the boys and the girls. So if we look at the boys first, it's unimodal. We've got a peak there at 22 lines jumped in 30 seconds at 3. Approximately symmetric. Not perfect once again, but it doesn't have to be perfect. Now let's look at the girls. The girls, it's unimodal. We've got a mode over at 25. So we had 3 girls that actually jumped 25 lines in the 30 seconds. This data set looks like it might be a little bit skewed to the left. So it's not as symmetric as the boys. And once again, the boys is not perfectly symmetrical. But you can see in the girls how a little bit skewed to the left. Our tail on the left there goes out a little bit farther than our tail on the right. So a little bit more interesting now than just looking at it in one group, right? We broke it into 2 groups. No, now it's a little bit more interesting when we're comparing the boys and the girls. So here's a box plot of the boys versus the girls, and the boys are in blue and the girls are in red. So once again, a little more interesting here. We can see in the box plot that our median for the girls is a little bit higher than it is for the boys. The girls, looks like they have a lower minimum than the boys do, and the boys have a higher maximum than the girls do. And it looks like the IQR is a little bit wider for the girls than it is for the boys. So we got a little bit more variability there in the girls' data. Now when we looked at the histogram, we noticed that skewed a little bit to the left, but box plot's not showing any outliers for the girls, so we don't have any outliers there, but it's just skewed a little bit to the left, but We don't have anything drastic or extreme that's showing up as an outlier. So now we're going to start looking at a different data set, and we're going to be looking at time plots. Now, time plot is a display of values against time. So this data set that we're going to be looking at is the count of home sales in 2019. This particular histogram is by quarter. Okay, so our first quarter of the year, January through March, second quarter of the year is April through June, and so forth. So this just gives us our counts of home sales. So once again, we're starting at a higher level. Okay, we're looking at it by quarter, and we can see there that looks like the majority of the home sales took place in the second and the third quarter of the year. So this next slide is looking at the same data set, but we're looking at it by month. So the 1 is January, 2 is February, and so forth. And we can see that we do have amount of data there, May, June, and July. And then also it looks like it picks back up in September. So we've got a lot of home sales activity in this zip code for May, June, and July, and then it goes down in August, and then it pops back up in September. So get a little better feel of the data looking at it by month than we did looking at it by quarter, right? We sliced it a little bit thinner into 12 pieces rather than 4, so it gives us a little different perspective of the data. So this time plot looks at our home sales data by day of the year. Okay, so we've got each day of the year and then the number of sales that corresponded to that day. Now if we look, it looks like somewhere around the 180th day of the year, we had a spike there of 12 home sales in that one day. So this is the same data that we've been looking at. We've just looked at it 3 different ways. We looked at it by quarter, by month, and by day. Okay, so if you remember what I said at the beginning of this chapter, you want to start with a high-level view and then start to drill down from there. You don't just want to dive into the granular data right away. Okay, so for this particular data, I looked at it comparing quarterly, monthly, and then daily. Okay, so looking at these, I would say that probably the best way of displaying it would be by month, because I think by quarter, they're a little too wide, the bins are too wide. You can't really get a good idea of what's going on in the data. The daily seems to be a little bit too much, a little too busy, that graph is, but the month seems to be a good representation. You can kind of see how your patterns and so forth go throughout the year. Now, with that being said, earlier in the section, I had talked about knowing what you want to know, right? What question are you asking? So it may be fine to look at it at the granular level for the day. It may be fine to look at it at a much higher level at the quarter. It all depends on what the question is that you want to answer. But just for general display, it seems like month gives the best display. Quarterly is a little too high level, daily is a little too granular. I think month might be good. Another option may be to look at it by week. That's also a possibility. Look at the patterns there for it by week. But I just wanted to give you an idea of how you can drill down on data and how you can kind of get either a good perspective or maybe you take it too granular and you kind of lose perspective at that point. So the last thing that I want to talk about for this section is using data to look into the future. And it's always very tempting to try and do that. And sometimes it makes sense and sometimes it does not make sense. Now, if you're looking at, for example, the home data that we were just looking at, it's reasonable to believe that your housing market is going to have a similar pattern year over year. Now, obviously, you're not going to have the exact same number of sales, but the pattern should be there, right? We saw a pattern where it picked up in the summer, and then we had a little bit of a pickup in September. Now, that would be interesting to look at prior years to see if that same pattern is there where you have that pickup in September. But I know that it does make sense that you would have a pickup in the summer. A lot of people are moving in the summer. They want to get into their new house before the school year starts and that sort of thing. So it would make sense that, May, June, and July, you would have a pickup. Now, keep in mind that economic conditions can have an impact on the housing market, but generally speaking, the pattern should be consistent. Now, in other cases where the data could be more volatile, think of a stock price. So a stock price that's increasing in value is not going to increase in value indefinitely. Okay, so you want to be careful trying to predict too far out into the future, because you could make a mistake and it could be a costly mistake. So just keep that in mind about trying to do too many predictions in the future based off of past data.